Hello engineers and welcome to another part of the Convert channel. I am Mansur Amini. In this session we are going to simulate a tank filling with its draining system as ben HYSYS and using dynamic simulation and jump into the dynamic simulation. So before starting the session we need three components, which is water, nitrogen and hydrogen to insert into the HYSYS and choose NRTL as your fluid packages, and let's go to simulate dynamic simulation of filling and draining tank. Before transition from steady state to dynamic, uh, the flow sheet should be set up and we can go to dynamic and click on the dynamic mode and changing our steady state transition and transiate actually into the dynamic mode. So insert water, oxygen and nitrogen and into the sulfur, which their mole fraction is given right here as I am typing. So after inserting this composition, go to condition and the temperature of 25 degrees C, pressure is equal to 3 bar, and mass flow is 4000 kg per hour. So after setting up your feed stream, let me change its name to the feed. Insert 3 valve into the simulation area. And insert a tank, actually a storage tank as well, into the simulation. So the inlet of the valve is feed, and we have two outlets for the tank as well. Just click on the equipment which you are going to insert and press Ctrl and drag your mouse to define the stream. And let me change this stream name to the air, press enter, and this flow is the water. So go to the stream number 1 to dynamic and make sure that you have activated this pressure specification and insert 2 bar for outlet stream of the first valve. Go to the valve, again go to dynamic and confirm that only pressure specification is active. Insert 1 psi, 1 bar and insert 1 bar for this pressure specification as well. So after your actually steady state simulation completely set up, you can go to the dynamic mode. So before transition from the steady state to dynamic mode, I have to go to the tank and insert volume of the tank, which is equal to 3 cubic meter. Close the tank window, go to the valve, inlet valve, and go to the dynamic and insert a sufficient of the valve, which means the amount of flow which actually that we have in the for a completely open valve in the criteria of 60 degrees Fahrenheit with the differential pressure of 1 psi. Insert 70 for this valve and 50% for the bottom valve. Just right here, insert 50. So click on the tank, go to the dynamic tab and add and configure level controller. After you inserted level controller into the simulation, its connection are completely given right here, which the process variable source is liquid level percent in the tank, and the set point actually, I mean, output targeted object is percentage of open, which in this valve we have. So go to parameter and set point is equal to 50%. That means we have half of the tank which is completely full of water, and change this specification and tuning parameter of the controller and insert 0.5 and 5 minutes for the TI of the controller. So after inserting this specification, go to the inlet valve again. Uh, go to dynamic and insert the PID controller to the simulation area and select variable, which is the mass flow of the feed. Find the mass flow, which is right here. Select that, and output target object is the valve inlet valve in the condition of actuator desired position. Select this, go to the parameter configuration and make sure that you have click on this option. So let me first insert the process variable minimum and maximum of 0 and 5 kg per hour respectively. Insert 0 for this one and 4000 kg per hour for the process variable maximum. And our set point is equal to 4000 kg per hour. So after inserting this criteria as well, change this parameter for the first valve, insert this criteria and 1 minute of the for the TI of the first valve. So after your steady state flow sheet complete, you can go to the dynamic mode. Click on the dynamic mode and transiate your simulation from the steady state to the dynamic mode. Click on make changes, finish, and go to integrator and insert 0.5 for example for the acceleration, which means amount of speed that we need to insert for tracking our dynamic simulation, time of our dynamic simulation. So end time is non-stop, which you can insert any number that you want to insert, but I leave this uh, end time empty. Go to dynamic. So let me say you something first. Go to a strip chart and add a logger. Click on the edit. Add valve, actually valve, inlet valve, liquid percent level, and for the LIC, the set point, which is SP. So insert these two variables into the simulation. You can close, you actually click on display to show you how your simulation is going to work, and drag the red marker into the left to expand the time axis for tracking your time. You can close all this window. Just make sure the initial level in your tank level liquid of in your tank is equal to 0, and press 0 just right here. Go to the dynamic, click on the dynamic mode and switch to the dynamic. And you can start the dynamic mode and watch out and observe how our feed is going to change in respect to the set point which we set right here for the applet valve, which is set at in 50% of liquid level. Press on run and watch out your simulation so we can stop the simulation. You have watched how our simulation work, and at the first of our simulation, our diagram was like something that our mass flow goes up and reach to the 50% and set in the 50 liquid level percent in the tank. So thank you guys, have a good time, bye bye.